So I guess we are enough to start this webinar. Thank you for joining us. Welcome everybody. I'm François Lacombe, French consultant working for the Tactivis Cooperative and partner in the Map Your Grid initiative, along of some of my colleagues which are here today. Tobias, Carlos, and David from Open Energy Transition, Katia, Emmanuel from Pipe Summit Surf Community, and Marina from Dinar Show. We are really happy to have you in this webinar to explain what we achieved along the last year for the Map Your Grid initiative, and we have a pretty long agenda. I will moderate these talks today, and even if everyone starts with a closed mic, you are free to ask questions in the public conversation you see on the webinar window. We plan to welcome live questions at the end of each part of this agenda, so we may take a few minutes to hear you if you have something to ask or you want to get into details for a given point. We wanted to address three main points today about this initiative. First of all, to explain the methodology we followed to integrate the Map Your Grid initiative in OpenStreetMap community, and more detail about the access of power data this community is producing since more than 20 years. That is for Marina and I, and then Katia and Emmanuel will deal with information about the usage of OpenStreetMap data and the impact it has on the energy system planning studies, mainly with Pipes Earth software, but also open source software in general. And we provide very nice insights on the impact it has. And as well, Carlos and David will use the power plants matching tool to deal more in detail with the power generation assets, and to combine several data sets to produce a very rich knowledge about those assets in many countries. And finally, we may welcome Tobias, that will propose some closing words about what we want to tackle in the future. I hope it's clear, and I will provide a few words of introduction. The point about all of this, and mainly the Map Your Grid initiative, is to deal with data quality for power grids, and intends to answer several questions about the point of the quality of this data, and mainly the point, the impact it may have in the energy system planning. We intend to solve a few questions. First of all, to identify which situation in which the level of quality is suitable for studies, or it needs to be improved, or how can we assess this quality, this level of quality in the data. And finally, how can we support the community that is producing open data for power grids? If we want to start with something, I think the best thing is to give you a few words about OpenStreetMap and why it matters in the Map Your Grid initiative. Even if the point is to build a digital twin of power grids, we have to present what OpenStreetMap is doing and how it helps actually with the production of such a data. OpenStreetMap is not a map, it's a collective database founded in 2004, more than 20 years ago, in a time we almost forget regarding sharing of open data for geographic matters. A time where we didn't have Google Maps yet. Google Maps appears in 2005, 1 year later, or we don't have so much IR imagery as well. And founders of OpenStreetMap take the risk to found this database where everyone can contribute to produce open data about what surrounds in the world, like roads, lakes, rivers, forests, land use, and even power grids. We used to map real life static visible objects in this database, and everyone can contribute. Right now, we have more than 6,000 contributors per day, more than 10 million registered users worldwide, and that's a very massive structure to gather cartographic data. Right now, it's the first OpenStreetMap cartographic database where you can get many information about some features and mostly visible features like Power Grids. You may know OpenStreetMap like this map, actually, but OpenStreetMap is more than a map. This map is the command base map produced with the data from the database, but I can instantly change it as the worldwide Power Grid map with just a few change in the software that produce the map. We just switch to the data that get the interest we want, and we show the Power Grid map. And that's the thing at a continental level, but we can get into details with way more details about grids, like substations, like power plants, for instance, an offshore power farm in the Northern Sea. And we can link the power grids with those figures. And that's the most important things, because sometimes you have data sets about power plants, sometimes you have data set about power lines, but right now in OpenStreetMap, we merge those two features and connect them. And that's really powerful to get this data. So it's not about maps, but it's all about database, actually. One very important concept mappers are very encouraged to follow is the verifiability, because if everyone can contribute in this database, they all must observe the verifiability principle. So at the core of OpenStreetMap, verifiability is a principle that get trust into data. You can verify every information that can be added by true or false statements by observable evidence. So we don't map hidden stuff, private information, but only the visible features that anyone can confirm they exist. And that bring a first step for trust into this data, because if everyone can verify if it's true or false, we are stronger together to get the most of the database. And that's very important. Regarding Power Grids, not all features are verifiable from ground or from air imagery, actually. A very large part of that is verifiable from air imagery, but some information may be found in public suitable data as well. And the very interesting part of the work of this community is that anyone can also use public data and make it in the database to conflate it with other features. And that's a very important part as well, when we combine what we see on ground and what is described in suitable public data with appropriate license and with appropriate agreements with data producer to use it inside the OpenStreetMap database. So let's consider everything that we'll show today is about data that has been verified, whether from ground or air imagery or for suitable public data. And that's really important to tackle many challenges we had in the past. This set, we may get into details about the data quality, because you may have seen that we have very detailed features, and I will let Marina to tell you about how we can assess and monitor the data quality of all this mirror stuff. Marina, let me give you the presentation.
Yeah, thank you, and hello everyone. So let's tackle the data quality issue at hand. On the next slide, you can see that we start with a simple question, which is, oh, that's perfect, actually. We start with a simple question, which is OpenStreetMap data usable? And to answer that, we use the FAIR principles that say that data should be findable, accessible, interoperable, and reusable. And by those standards, actually, OpenStreetMap performs really well. The data is findable because you can go to openstreetmap.org and it's there. It's accessible because you don't need an account. There's no paywall. It's interoperable because there are a plethora of tools and apps and programs that already rely on OpenStreetMap. And it's reusable because you can use it internally and then share it externally at a scale provided proper attribution. So from a FAIR perspective, OpenStreetMap checks all of the boxes. But that immediately leads to a next, more critical question, which is usable data always quality data? And the short answer here is no. Having fair data does not guarantee that the data is good enough for operational or strategic use. You can have data that's accessible, open, reusable, and so on, and it is still unusable for decision making. So we wanted to go one level deeper here and ask ourselves the question, is OpenStreetMap data quality data? So we define data quality around three core principles. If your goal is to build a digital twin of a power grid, these three principles are non-negotiable. Starting off with consistency, it basically means that data should have a structural and logical coherence. Very concretely here, this means that you should ask yourself the question, is the power infrastructure correctly mapped? Are substations, line voltage levels, and connections logically connected in OpenStreetMap? Does the network actually behave like a network or like a collection of disconnected objects, and so on? Moving on to completeness, this is where things get a bit trickier because there is a sort of paradox. How do you know your data is complete if you don't already have complete data to compare it to? And you can't simply answer the question, is my data complete, by looking at a single data set in isolation. Here is an example on the screen. You have three different sources telling you three different things about the length of your power grid. So what do? Who is right? Is there someone who's right? Are all data sets wrong? Do we assume we need to meet in the middle and do an average? Are we even talking about the same infrastructures in the data sets, and so on? And this is the point here. Completeness only emerges through comparison and cross-validation. And in that sense, OpenStreetMap will not necessarily tell you who is right, but it will act as a signal that there may be inconsistencies in the different data sets. And then last but not least, you have up-to-dateness. And this is important because obviously a power grid is not static, and assets are built, reinforced, rerouted, dismantled, and keeping data up to date is not just about having update processes in place. You also need to assess the effectiveness of these processes. And in OpenStreetMap, this can be done by answering some of those questions that you see on screen. Who is actually maintaining the data? How many contributors are there? Are they local? Are they continuous? Are they still active today? And then on the feedback side, how are we collecting the feedback? What's the feedback loop? How does it work? How much time does it take? And much more. And so to answer those questions, François.
Thank you, Marina. So, a very important fact about OpenStreetMap as well is it is already completely fluent to describe power grids in its data. What I didn't tell you in the introduction is OpenStreetMap contains a very basic set of features, points, lines, relations. And what makes the difference between features is tags. We actually put tags on everything, and it allows to distinguish some benches from trees, from power transformers. And we already have a very extensive set of tags to describe the components of power grids, towers, lines, substations, anything visible from the grids, to distinguish and also to put properties on them. To not only say, okay, this is a power line, but also how many cables there are or at which voltage it operates. And that's definitely make a difference between other solutions because everyone can complete the features, but also their properties. And that's a pretty unique worldwide applicable vocabulary to describe those grid elements and to make, let's say, the grid of one country comparable to another that is barely achieved in other datasets because they may focus on a given country and not the worldwide scale. You may learn about the power tagging in the page I mentioned there to get a very broad overview of what we are doing regarding that. But let's get into details about the process we can put in place to not only contribute to this data, but also reuse it. And I want to propose you some 4 steps to follow to explore how this process could be. Currently, we can start from a very broad set of public Power Grid data sets that are available for OpenStreetMap contributors to reuse in the contribution tools we have and contribute to the OpenStreetMap database. This public Power Grid data is used in combination with other sources like aerial imagery or ground survey to state if what is present in these data sets is correspond to the reality on ground. And people are assessing this constantly, using this in their contribution tool and populate the OpenStreetMap database according to what they see. That's the first step, a very basic OpenStreetMap contribution. We can complete the landscape with 2 kinds of tools. The first of all is the quality tools we are using to detect, let's say, some errors. For power grids, it will be disconnected power lines, unachieved power line, unfinished, inconsistent voltage connection, for instance. Some very objective errors we can find in the data sets. And it can not only be used by contributors to fix their contribution, but also for reusers to clean up and create the data that is available. The second kind of tool is monitoring tools to know how people are contributing, how many people, how many features, where, how often, to get a very broad insights about the kind of contribution and how it is the most intense one. Those tools outputs can be aggregated in some other tools we are about to present you right after. I named the Green Inspector that combine the errors we may find on the measurements we make on the contribution to provide some high-value insights, to updates, to make decisions as well, and to be useful to contribution to organize their contribution at a country scale. And that's the first step. And the last step is the feedback. And this is kind of a view that's not so in place today. And we wonder what would be the best method to get the outputs of the grid inspector, for instance, or the other errors or measurements we make, and provide useful feedback to public power grids data producer. It could be institution, operators, anyone who produce this data and can be improved or conflated with OpenStreetMap data. And that's the first step that will create a perfect loop to iterate on and to improve not only the OpenStreetMap data, but also the public grade data available. And that's the process we aim to install with Streetable tool, open source software, obviously, open data, and collaboration between OpenStreetMap and institution.
Yeah, we wanted, thank you, Francois. We wanted to show you our workflow, how it applied on a real national transmission grid. And it is in Colombia, where we've invested heavily in power grid mapping in OpenStreetMap over the past several months. It became a real testing ground for our tools and methods, and we will see now this more in detail. What you currently see on the left of the screen is a graph comparing what already existed in OpenStreetMap before early 2025 that is shown in black. Then in orange, we can see what was recently mapped by our team, and in green, what was added by other contributors. And then on the right of the screen, you can also see the stats on the Colombian power infrastructure as they currently exist in OpenStreetMap. And what you need to know here is that around 75% of the transmission grid in Colombia was already present in OpenStreetMap. And that's thanks to nearly 20 years of community contributions and efforts. And our goal here was to see how we can improve the existing grid. Was there any available data that we can use to do so? And what tools could be used to measure these improvements? And so to start off with imagery, for our mapping, we used satellite imagery available in OpenStreetMap. So this is Bing Maps and Mapbox imagery that you can see on the left, S3 world imagery that you can see in the middle. And as you can tell, those images were not always super high resolution, and the imagery was actually not always up to date. So we complemented that with Mapillary street level open source imagery and control aerial imagery from EGAC, which is the Colombian National Geographic Institute, that you see on the right of the screen. And you can immediately tell it's much more crisp, it's much more high resolution, and we were very glad to have these images when they were available, because that made our work much, much easier. And then on the data side, we compared several data sets, starting from the right this time. Obviously, we used OpenStreetMap data. And then what you see in the middle and on the left of the screen, those are different official data sets coming from UPME, which is the mining and energy planning units, and ICSEM, which is the Colombian system and market operator. So this data is available online in the form of grid diagrams and planning documents that you see on the screen. And what you need to know here is that we used ICSEM and UPME data as hint layers in OpenStreetMap. And this is very important because we do not import data into OpenStreetMap. So first off, everything is done manually, which means line by line and substation by substation. And secondly, if, for instance, a substation or a power line was present in an official data set, but not verifiable in OpenStreetMap, we simply did not add it. So no visual confirmation means no mapping. And because we were doing this manually, as you can imagine, this took us months. We essentially went through the entire Colombian transmission grid with a fine-tooth comb, constantly comparing the official data sets from ICSEM and UPME against our crowdsourced one, which was OpenStreetMap. And we can already talk about some of the findings of this experiment. And first, there were cases where all data sets matched perfectly, and that was the dream. We absolutely need more of that. Then there were also cases where the official data sets disagreed with each other, and OpenStreetMap actually helped us determine which one reflected reality. And there were also cases where OpenStreetMap was actually more up to date than one or both of the official data sources. And for example, on the slides here, you can see a 220 kilovolt line present in OpenStreetMap on the right image, but missing from one of the official data sets, the one on the left. And of course, the reverse was also true because there were cases where OpenStreetMap lagged behind, and that was often due to old, low quality or cloudy satellite imagery that was impossible for us to use. And as I said, we did all of this manually, but manual cross-data validation is obviously not the end state because grid mapping can be partially automated with detection tools. For instance, OpenStreetMap data can be compared with Earth observation datasets and can be challenged, validated, expanded with, for instance, a substation detection tool that can help identify substations that are missing in OpenStreetMap, validate existing locations, enrich attributes like voltage levels and others. And another example is power line detection over water bodies. This is what you see in the image on the screen. And these segments are easier to detect from imagery and can be useful to validate line geometry and confirm the number of cables and circuits on a power line. So yes, parts of the workflow can be automated with time, but right now we are going to show you our existing tools and what we use to measure the improvements that we made mapping over the past months. Press one.
Indeed, thank you, Marina. And the next point we want to make in getting to details of that process is to show the quality insurance tool we use, which is called Osmose and is global in the OpenStreetMap community. Osmose is a platform that assesses some checks based on rules and seek for possible errors we may make during the contribution. So I show here a perfect example for power grids where Osmose detects an unfinished power line and asks us to complete it depending on the data we have on the moment we see the warning. So Osmose provides a very rich interface to show not only the warning, but also contextual information, for instance, the voltage of the line concerned by the warning, and also provide some help to solve the problem. So Osmose is the first step of error solving in the process. We will see some tools that is more global in this work, because here we have only warnings depending only on one category, and we have to display all categories to get an extensive view of what is causing problems in a given country. That is more oriented for contribution than for usage, and we developed actually some tools that Marina will show you right after to make this data more usable for reusers. You can go on, Marina, if you
So building on Osmose, we can detect and classify errors in power grid data. By comparing the number of errors to the size of the network, we turn that into quality indicators. And to make those indicators easy to read and visible at the country scale, we built Grid Inspector, which is what you see on the screen right now. And Grid Inspector provides a global quality score per country. The goal here was to allow anyone to quickly understand the quality level of OpenStreetMap grid data in a given country, but also to enable comparison between countries, because it's only with comparison that you can put results into perspective. And finally, it's also to help mappers clearly see what needs to be improved and where to focus their efforts. So this quality view that you see includes 11 KPIs like attribute completeness, for instance, cables, voltages, circuits present on a power line, but also topological consistency, meaning towers connected to lines, lines connected to substations, and then voltage consistency across the grid. And these indicators helped focus our mapping efforts on the attributes that mattered most and directly helped us improve Colombia's overall quality score, as you can see on the screen.
Another tool we have is the dashboard that's displaying the contribution KPI. So when I introduced the process, I talked about the measurements we make on the contribution. So this dashboard is intended to present on any country and at world scale too, the figures of the contribution. So how many lines we have, how length are the circuits, or how wide are the substations, and how many mappers did that in the country. So this dashboard can be found on the address you have on the screen, and it's completely public to observe what's happening in the power data available in OpenStreetMap. And that's really important to make the appropriate encouragement in the local communities to see where it rises, to see where it's lower, and to organize the projects. But that's something that should be built in any GIS, actually, to measure the contribution of the people responsible to maintain the completeness and the quality of the data. But that isn't really usual in this field. So we made it dedicated to Map Your Grid, but that's something we should extend on the whole OpenStreetMap database as well. Marina, you may want to complete with coverage view, maybe.
Absolutely, yes.
Yeah.
So linked to our contribution monitoring dashboard that you just saw, we also included a coverage view in Grid Inspector that you currently see. And here we compare official circuit length data with OpenStreetMap data. So for this, we created an open global transmission length index that we integrated into Grid Inspector, and Tobias just put the link in the chat. So for Colombia, you can see that the coverage score is a bit lower actually than the quality score because there are different indicators at play here. And there are also some countries in gray on the scale, which means that circuit-led information was purely not publicly available, or at least we could not find it online. But when we can obtain circuit lengths by voltage levels, it becomes extremely valuable because it allows us to identify missing segments in OpenStreetMap. And this global coverage score that you see is weighted by voltage levels. So it better reflects the strategic importance of high voltage infrastructure in the power grid, which means that in the computation, a missing 50 kV line does not weigh the same as the missing 500 kV line. And then we also created one last KPI that is a spatial indicator that detects whether substations are present around densely populated areas, and mapped visually. This helped us actually identify cities where a substation logically should exist, but was not yet mapped in OpenStreetMap. And this means that it helped us find what was missing by geography and not just by attributes. So taken together, the quality view and the coverage view in Grid Inspector provides us with a comprehensive diagnostic of power grid data in OpenStreetMap. And today, this tool is a functional beta that you can go ahead and explore. As you can imagine, we have ideas, plenty of ideas for the future. We would like to add new validation rules, new indicators, improve the user experience, and also add assessments at a regional level and not just on national level. But for now, the best thing you can do is just try it. Tell us what you think. Maybe you also have use cases that you can bring to this tool and that we can discuss. So speaking of what comes next, Francois could tell you a bit more.
As a conclusion, we identify some very important challenges we want to tackle in the future regarding this quality assessment and this global observability of the OpenStreetMap data. And first of all is obviously to develop and maintain core tools. As you may have understand, we certainly have developed some tooling of our own to observe some defined KPI, but mostly we rely on the global OpenStreetMap ecosystem software like Osmose, Podoma, for instance, which are two important tools, editors as well, which are really important. And the challenge is definitely to develop and maintain those tools and be useful to the community by the initiative we lead on this particular domain. And that's something we want to invest some time because it's really important. That will allow to intensify mapping where data gaps matter the most, because we obviously identified some countries in which it would be really interesting and important to invest sometimes. And currently, we lack of connections or lack of encouragement in some communities, and that's very important to support them. Why not with connections to local associations, for instance, or whatever. But that's the second challenge. And the third challenge is to bring community and institution together. And that will have two very important outcomes. First of all is to mutualize the common efforts and take the best out of the volunteering effort, but also from the institution power to bring this data in consistency and completeness at the best level. And also to foster alignment with both institutional data standards and also OpenStreetMap data standards. We already identify some really important standards that would be interesting to put together with OpenStreetMap tagging. I think of one is the SIM model that should be compared to begin with OpenStreetMap tagging, and then why not adapt it, extend it, or whatever, both in OpenStreetMap and SimSide, we don't know, to align the data and reinforce the data interoperability between database, and mainly the open databases, not only OpenStreetMap, but also Wikidata or also public data sets available about different features of power grids. And those 5 challenges will compose our roadmap, I guess, in the coming months or years, maybe, because it won't be done, I guess, completely in 2026 years, but that should be done in the past. By the way, I thank you for your attention on this first part, and we may have some few minutes to take some questions. If you want, you can use the raise your hand control and the right bottom corner of the screen to ask for the speech if you want. I don't know if some of my colleagues want to insist on some important question we may have in the chat as well. Maybe possible. Yes, you can open your mic normally if you want to speak.
Hi, good evening. I hope you can hear me. Apologies, I jumped in from another meeting and I think I lost the first most important 20 minutes. So I think my question will be, is this session recorded? Can I have access so that I can go through what was said in the first 20 minutes? What was very important for me was the quality assurance part. Currently, I work on a project that does electrification planning basically in Nigeria, and we have been able to map the entire medium voltage grid lines in Nigeria. So I was so much interested in the quality assurance because now we are looking to go deeper to begin to map the poles, the cables, and everything. So please, I would like to know if this will be available. So maybe when I rewatch the first 20 minutes, I hope I can reach out to you personally via email to ask any questions I have. Thank you.
So thank you for question and interest in this matter. Yes, the webinar is recorded and you will have all access to the first 20 minutes and the slides we presented. I think you can have a look to the links we already shared that may be applicable for Nigeria. I think most of resources are available for this country. And that's a really good opportunity indeed to have a look to not only transmission data, because you may have understand that we first of all focus on the highest level of power grids in countries because that are the most visible parts, but distribution grids are also in the interest for this tooling. Obviously, Osmose and quality insurance tools also observe distribution grids may have custom sets of checks for that voltage levels, and that will be perfectly usable for your usage there. And I think that could be a great opportunity. Indeed. I've noted your coordinates, and we may get back to you to discuss more in details about this project.
That's fine. Thank you.
You're welcome. To remain on track of this webinar, I think we could go to the second part because the time is running. I'm sorry, Gregory, but no matter what, you may be able to ask your question at the end or even in the chat. I will let Katia present the next part about the data impact study, and we get another round of question right after. Just give you the presenter role. Katia, here you go.
Thank you very much, Francois and Marina, for fantastic first part. Now we will take perspective of energy modelers to see why those data, why OpenStreetMaps database and its energy-related part benefit literally everyone. So currently we are in the stage which is called energy transition, and that is kind of civilizatory level shift. And if we would look into the past, we will see that there is quite a number of features, and we would need an additional lesson to understand what were all those pitfalls which didn't allow a number of energy transformations to work as they have been intended. But there will be always one common features between those features. It is lack of planning. And that is why we do need energy planning, and that is why we do need credible energy modeling. Actually, success of energy transition in Europe is built upon prior energy planning and prior energy modeling. So we have currently a number of open source models for energy sector, and this activity has allowed to create environment from which successful energy transformation has grown up. And modeling has allowed to have vultures in virtual space instead of facing them in reality. But if we would take the global perspective, we will see that there is still a lot of things to do. There is need to harmonize modeling approaches, and there is need to get better data. And this global perspective and this need to get energy modeling right for every part on the Earth is a motivation behind PIPESA-Earth model and PIPE Summit's Earth community. So our motivation is the fact that energy transition knows no borders. We have the same Earth, we have the same atmosphere, and we need to go through energy transition together. And energy planning tools, state-of-the-art energy planning tools, are needed in every part of the world, whether it is European Union, whether it is Nigeria, Colombia, and everywhere. We need data and we need credible models. So that is why we have built community, we have built model, and we have built community. And now we are growing applications in academia, in education, and also in policy relevant studies. PIPESA-Earth is taking place between, that is a part of chain between global models, those theoretical models which give you an understanding on how global economy is working, and between actionable development plan on regional levels. And OpenStreetMaps is a crucial part in this story, because grid data is the very important input for energy system modeling and for energy planning. And official data on grids are available for only very few countries in the world. So that is why we needed to build in PIPESA-Earth, we needed to build the whole workflow, the whole chain of software, a whole chain of software routine to collect and prepare data and to build model on them and run optimization. And OpenStreetMap data were crucial input to get power grid data. We have developed a dedicated procedure which allows to post-process power-related data extracted from OSM and make them fit for energy system modeling. And it has taken us a couple of years to get it working for the whole of the world. And now we have tested the model. We have tested PIPESA-Earth for all parts of the world, for all 300 plus United Nations countries, and we know that it is functional. But another question is if it is accurate and if it is correct. And to answer this question, we need reference data. Due to the mere fact that reference data, official data on grid, especially quantitative data with transmission capacities, are quite rarely available, it is always very good luck to get good references, to get good third-party sources against which we can compare OSM extracted power grid data. And this work has been done for Europe. We have learned that regional tailored modifications, regional specific tweaks in this post-processing of OpenStreetMap's data are essential, but that accuracy can be compatible or even higher as compared with official data. So this work has been done for Europe, and now we must do the same for the rest of the world. We have a number of assumptions to restore transmission capacity data, transmission capacity which is essential for energy system modeling, which is one of the crucial inputs. But there's still some challenges when we start applying it for different countries. We see that there's still some ways to improve, which is actually also consistent with lessons learned also in European studies. There is still need to align our procedures with regional reality, and we are lacking reference data. And also, there are still some parts of the world where OSM topology, OSM extracted topology is not complete. And in this case, we still have successful examples when people just request official data for such countries. In particular, 2 years ago, it was the case for Bolivia, when data have not been, or OSM data have not been completed for Bolivia. And the colleagues have requested data from official sources. And it was quite significant additional work which they have done to coordinate. It worked, and academic study which they have produced is amazing. But we have also observed that it is not the way for everyone, because it is a lot of additional work, and one of crucial prerequisition for this work is that official structures actually are ready to collaborate, first, and second, that they do have such data. So we need some other solution. And to get this solution, work of MapUGrid initiative was indispensable. It was amazing because we have now data set of reference data on grid, and looking only into 2 cases has still allowed us to understand the reason of discrepancies which we have seen before. And now we have, actually we have found that those assumptions which we have inherited from European model do not work well around the world. Actually, it had to be expected, but it was tricky to understand what is wrong. And now we have found that we have found what should be adjusted, and we have sketched a prototype which we are currently testing on some case studies, and which we are planning to integrate into the whole model. So there is some infrastructure which allows us to join efforts. There is database, ASOM electrical grid mapping, which contains precious data sources, precious official data sources for basically all countries around the world. And there is Pipes Earth Status project, which joins effort and provides reproducible procedures for validation. If you are interested to understand how well your power grid reproduced, please feel free to refer those 2 sources. And now we come to the sensitivity analysis, to the modeling study. Actually, if we would take power system model, we will see that there is a lot of simplification. We are using simplified topology, we are using clustering, and the resulted model of the network is actually not exactly what we see on the map. So the question is, if it looks so simple, probably all these additional lines, all this care, all this accuracy about which Marina and Francois have been talking probably doesn't matter. And what we have done, it was just a numerical experiment. So we have taken Colombia and we have built energy system modeling study to quantify the effect of improvements which Francois and Marina have shown for Colombia. So just as a reminder, Colombia is a country where power system has a higher share of hydropower, but expansion of hydro in future is limited, while solar and wind potential are high, and solar and wind generation is expected to expand quite significantly to cover increase in the electricity demand. And we have created a data set to get this sensitivity study right. We have created special software solutions which allow for reproducibility. Emmanuel, I think it will be best if you would talk about this yourself, because you have been creator of this part.
All right. Hi everyone. So to make the grid modeling reproducible, so we rely heavily on ETH OSM package. So this was developed by the Pipeside community. So the Pipeside, the ETH OSM package is an engine that we use to extract power infrastructure features directly from the OpenStreetMap. However, we faced a challenge. So the OSM is actually a database that changes every minute. So to address this part, we started to work on a feature to retrieve historical OSM data. So this feature basically acts as a time machine for our pipeline. So it allows users to select specific timestamp. Then you can retrieve the state of the grid exactly as it was in the past. So this is very crucial because it allows us to reproduce previous sensitivity studies that have been done in the past. And more importantly, you can also quantify how much the grid model has improved over time as mappers had new data. I think I can hand it over to Katya as we move to the next slides.
Thank you, Emmanuel. It has been breakthrough in our energy system model, and everyone who is interested can reproduce the same quite easily. So, and apart of getting grid right and reproducible, we also needed to do validation of installed capacity. David and Carlos will talk in more details about why installed capacity is important and which pitfalls, challenges and opportunities do we have in this part. What is important now is that for Colombia, we have managed to reproduce structure of installed capacity all right, and generation mix also corresponded to the reality for the year which we have, for the year from the past which we have been reproducing, also accurately enough. Then we have built a number of scenarios. They are shifted somehow, they are somewhat shifted into academic space, and we have been interested in particular in decarbonization ways. But we have been trying also to be as realistic as possible using APME data and using Pipeside technology data to account for evolution of technologies, costs, and electricity demand. And the design of the study looks like that. We have 3 topologies of the networks, which correspond to 2 of them correspond to years from the past, and there is also the latest version of OSM data, which provides topology close to the reality. So you see how huge was the progress of OSM mapping, and you see that this progress is transferred into model. And now we had apply those 3 topologies in capacity expansion model. So for each configuration of the grid, we have run an optimization study and have obtained capacities, expanded capacities for generation, storage, and transmission. And each configuration was optimal under particular topology of the network, under particular spatial structure of the power system. After that, we have taken those capacity and fed them into operational model, which didn't allow for capacity expansion anymore, and which has used the latest grid data. Actually, what we have expected to see was that least accurate, least complete data would give the most expensive power system. But that was not the case. Actually, the simplest configuration from OSM 2020 gives very nice result for energy planning. And when we have started to investigate the reason, we have found that this distortion in topology basically has provided us with a completely different picture of power system, where load is located exactly at hydropower plants, and somehow load is almost always covered by available runoff, and actually everything is very nice. You don't need much to add, in particular, much more electricity storage. So it was a bit of surprise. And when we compare this installed capacity, optimized capacity, which we must add for solar and on wind generation and storage capacity for batteries, we also see very different pictures depending on OSM data which we have used. And frankly speaking, if we are taking not very accurate grid data, those inputs, those capacity expansion results are not so, do not have much to do with the reality, speaking in the plain language. But once we feed those nice expansion data into operational model, we see that power system which would fed with those inaccurate outputs of planning would end up in not very nice operational features. In particular, there is high share of unserved load, and there is quite high curtailment for generation which is placed in wrong locations. So long story short, you can use inaccurate data, but the effect may be not as you expected it to be. So you may get not only more pessimistic result in energy planning study, but also more optimistic. And what is inside the model? There is some clustering effects, and there are some interactions between clustering of grid and clustering of areas where you gain renewable potential. That is a bit of research question, and we don't know yet a proper answer on what should be the robust clustering algorithm, which would be immune against those uncertainties in grid data. And for now, what we can recommend, basing on results of this sensitivity study, is to use accurate data, is to doubt in quality of the data which you have, cross-check, validate, and improve those data if you see that something is not completely right. Otherwise, you would end up in a planning study which is misplacing investments and which would put you a transition pathway for the power system into those into this long list of vultures which we have seen in the beginning of the presentation. So, and there is for sure synergies between OpenStreetMaps and energy system modeling. My feeling is that we may even not see them all right now, but we see at least a few points at which we can concentrate now as community to improve quality of available data and to make accurate and state-of-the-art modeling and planning tools available and accessible in the points where they are especially needed. So first of all, there is for sure need to improve further quality and coverage of energy relevant OSM data. And that is why what Francois and Marina have shown in the first part of presentation is highly relevant for everyone who is interested in energy modeling and energy planning. While in the modeling workflow, there is need to improve also post-processing. And here regional expertise is crucial. We need more reference data. We need parsing of the existing reference data available in ASOM electrical grid mapping. We need to parse them into modeling ready, into validation ready form. And we need to enhance that. And we also need to deal with clustering improvements. That is research relevant part. And it is impossible to tackle all this without your help. While we can still provide you some support on validation and on contribution into better power grid data. So if you're in doubts, please feel free to contact us through Discord, through issues. Please feel free to join Map Your Grid community. Feel free to interact with Pipes Emits Earth community. We have Pipes Earth status, which is automating validation, and you can get support from Map Your Grid community to get your power data right. So our plan is to advance further on OSM coverage, enhance routines, OSM post-processing routines inside Pipes Earth workflow, crowdsource insights on input which will allow us to get transmission capacity correct for all parts of the world, how it was done for Europe, and create harmonized data sets which correspond to industry standards and allow proper energy planning for every country on the earth. And now, if you have any questions, very happy to answer them live or in the chat.
Thank you, Katja, so much for these very crucial insights on the modeling. As we done previously, you can raise your hand if you want, if you have any question. We have some time to discuss. We had more time, actually, and that will be a pleasure to have this discussion live if you want. I see, Grigory, you raise your hand, so you can open your mic and speak, please.
Of course, it's potentially difficult to do because the historic data in OSM may not have matched the reality of the grid at the time it was mapped. But have you seen any discrepancies between the way that the true grid has been planned and developed in a country versus what your model would have recommended on historic data? How well did those align? Do you see any efficiencies maybe or improvements that might have been made with better data?
You mean in the existing grid?
Yes. So essentially, do you think that the decisions which were made in the grid planning were as good as they could have been, if I was to phrase it in another way?
Frankly speaking, we didn't ask this question, but what we can do is to identify parts where the current grid should be enforced, should be fortified, where grid expansion does make sense to answer to face challenges of the future. In particular, if you need to build new wind and solar generation, normally grid would benefit from expansion in some parts, but looking for errors or looking for suboptimalities in past grid planning, we didn't try to do so. And frankly speaking, I am not sure it would be wise from our side.
Maybe also something about this. It's actually very interesting what you're asking for. So it could be interesting to prove that bad data quality in the past was leading to false planning. But unfortunately, the situation is like this, that we don't know nothing about the data quality of system operators. This is like a complete unknown field by science in general. And I think even there's no real standard around to assess quality in grid data, GIS grid data. And that's why what we are doing is quite new. So it's definitely very interesting, but we really don't know about the data quality of system operators who are operating those grids. We really don't know, and that's why we could suspect that they have a lot of problems there, because they don't have any tooling and there's no science around it, but we don't know. So what most likely, there are issues created in planning in the past that we feel today because of bad data. In some countries, especially, we've seen in Africa and in Asia that there are countries really that have problems to update their own transmission grid maps. Like, for example, one country that approached us was Myanmar, where this happened.
Quickly add that as Map Your Grid, we are also quite open to work with system operators and transmission operators in order to help each other bridge some of the gaps that we might have on either side, and obviously to improve planning as much as possible in any way. So if I know there's some system operators right now in the audience as well, so feel free to reach out so that we can establish some next steps that we can basically and we can basically start working on them.
Thank you very much.
I would also add that in the past, we, as I was explaining the feedback step in the process we displayed previously, in the past we had particular discussion with some TSOs to investigate some differences between the grid data and the OpenStreetMap data we see on ground, especially in Europe, and we can continue and probably automatize or make it more efficient of such process to investigate errors and mistakes on both sides, because we know that we may make mistakes in OpenStreetMap too. The point is not to not make mistakes on our own, but to be collectively more reliable because of the different origin and opportunities we see in the data production process. And OpenStreetMap has its own set of practices. The TSOs may have very relevant one as well. And by bridging it together, it will be definitely more efficient and obviously more quality as well. I don't know if anyone else has questions. We still have time to handle them. Do you have also reaction? You may share your own experience if you want.
Hello, Greg Lind from Minneapolis here. What do you think is most needed in the project right now in order to further your reach, scope, or capabilities? Make your ask.
Thank you, Greg, for asking. We indeed shared some challenges regarding the quality assessment previously, but there's also needs for energy system planning. I think currently, I could let Tobias complete as well. I think we can make a great progress on the data conflation. We have to investigate differences between the data we see produce and develop the tooling as well. And Tobias, you can complete if you want.
Yeah, like we had to speak frankly. Like we had last year, we had philanthropic funding from Breakthrough Energy. And for this year, we are looking for new grants, but also services to support actually the, especially what was really very good was really training of local groups. So we did a lot of training in Myanmar, Western African Power Pool. We are engaging with other partners in Africa to train those groups and to maintain the data over the next years, but also to expand for example, the quality assurance that we just have shown with the data that actually will be shown in the next presentation. So we could expand this grid inspector to power plants. We have actually all the data, but we just have not the resources at the moment to also invest that much into development. I think this is also an important thing we are investigating. And then it's really about we are investigating also to automatically actually run checks on all grids around the world against energy system models to then not to do more or less the sensitivity study that Katja just explained automatically, to see where new data actually changes the outcome of an energy system study, but in a more automated way. So a lot of, let's say, quality assurance that we are investigating, how to improve quality, investigate issues, and empowering the existing community with better training, better tooling. This is what at the moment where we are seeking for more capacity.
And if I can add energy modeler perspective to our wish list, that is estimation of transmission capacity.
Exactly, yeah, this is another very interesting thing. Like if you would have a line type catalog per country, like Katja developed for Colombia, then actually we could estimate the capacity much better using PipeSA and PipeServe.
An important point we can make about what Katja just said, because OpenStreetMap is providing the static data of the grid. We don't provide some dynamic status, obviously, or even capacities, and particularly of lines. We had this discussion with the community and seek for opportunity to make the most appropriate bridge between the static topology OpenStreetMap is bringing and the available capacity data online. And we saw that there's no point to put direct capacity data in OpenStreetMap with better working on bridges. So better identifiers, shared identifiers, and interoperable data between the different repositories. So that's an important point. OpenStreetMap will provide the topology, and then you will have to put on top the capacity data, for instance. And I guess we will have more extensive information about that, about the power assets generation with Carlos and David as well. So yes, always the combination of several components is really more powerful and important than to make the data available at a single place. If there is no more question, we can give the floor to Carlos or David for the last part, and it will enable some further conversation at the end, if possible. I guess I will give the presenter role to David. Is it right?
Thanks, Francois. Also, to me, it's possible because I'm going to start the presentation.
Yeah, you are.
I can see it now. So I think you can see my slide.
Thank you very much. We have had very interesting presentations. So in this opportunity, I'm going to present with my colleague David Diaz. We are going to present a hands-on activity mostly. We are going to be talking about two tools that we have been working on developing. And we are going to go into more mostly, let's say, code and details and how we can do it, the things. Hopefully, in the future, we are going to be able to show some data and comparisons in order to have some figures and numbers that we can discuss and compare. So basically, what I am going to present is about power plant matching. This tool has been developed by the PipeSat team and consists on getting several data sets that contains power plants and also locations and some very relevant information about power plants. What it does basically is comparing different data sets. Some data sets are focused on countries, other data sets are focused on continents, and some others are globally the scope. But some data set could have some plants that the other data set doesn't have. So what it does, this tool is trying to get one compiled data set that include all power plants, but at the same time identify those who repeats or are duplicate in the different data sets in order not to having duplicate plants in one compiled data set. And then I'm gonna be talking also with the OSM power plant, which is the tool that we recently delivered, and try to cover or fill some gaps that we have identified. So I'm gonna move to the next slide and I'm gonna try to show a very simple graph or diagram that try to explain what are the gaps that we identify. So for example, power plant matching, as I already described, contains some data sets with power plants. In this example, has GEM data sets, which is a global scope, and ENTSO-E, which contains data from Europe. And this power plant matching constantly is adding and identifying new data sets to compare all of them in order to generate this compiled data set that I have explained before. However, what we have identified is that OSM data.com we can generate that data set from OpenStreetMap. Has not been included as one of the data set source for this power plant matching. So our target as a modeler was to try to collect all the information, power plants that come from OSM and generate a data set. And that was a very complex task of the nature of the heterogeneous tags and reach of data that we can find for power plants in OSM. But at the same time, as mappers from different parts of the world, they have different understanding of how to produce and create these data sets or these particular generators or power plants. We can find some discrepancies in the data. So at the end of the day, we noticed that generate a data set from OpenStreetMap associated with power plants sometimes is very challenging. And I'm going to explain why this is the situation. We developed this tool, which is called OSM Power Plant. And this power plant, this tool, what it does is parse the data through OpenStreetMap and generate a data set of accepted plants. So those accepted plants are plants that, or are particular plants that contain mostly the basic information that we need as a modeler to include in appropriate data sets. But at the same time, there are some other plants that are lacking for some information. And in that case, this tool that provides is a rejection tracker. And this rejection tracker, what it does is listing all the plants that were rejected and also include the reason why they were rejected. So what ideally, our workflow using this tool is then providing this rejection list of plants with the reason, and then use the JOSM in order to prove the quality, to correct or enhance those plants in OpenStreetMap, And then again, we close the loop running again the OpenStreet, the OSM Power Plan package. And we hope that those plans no longer are going to be rejected, but they are going to be part of this data set that is produced for the OSM. One of the benefits of looking for this approach is that we, in my case, as an energy modeler, we are able to get more rich data set that includes new plants that probably the previous data sets like GEM and others may not have. And we are going to get more power plants and more information associated with the region that we want to analyze. For the other side, we notice that this workflow using this package also helps data creators, that they can find new plants and they can later include these new plants in the data set they are producing and creating. And also we have noticed that the OSM mappers also benefit for having a list of plants that has some needs of enhancement, and using the conventional tools they have, they can improve the quality of the data. So using this tool, OSM Power Plan, we try to connect all different stakeholders, we could say, and try to benefit the complete process. Just for going into more details, in the terms of OSM mappers, we can see that the process or the workflow is the following. They run OSM power plants, they extract the power plants using Overpass API, and then they have this rejection analysis that lists 27 rejection reasons, and then they have the possibility of fix in OSM those data sets, and then we are going to have a more consistency in the platform. The second group is the energy modelers. They run these OSM power plants. For example, I've been testing the configuration for Europe, and for example, we have been able to detect 12,000 plants that in overall capacity is about 500 gigawatt of capacity, installed capacity. But then we use power plant matching and include OSM and compare with the content of other data sets. And finally, we noticed that there are about 11 gigawatts of new capacity that was not included in the other data sets. So of course, this is an example for Europe. It depends significantly on the configuration we have, and we need to improve the configuration in order to fine-tune somehow this process of parsing the plants and getting more plants that are accepted and less or less plants that are already rejected. And the third group is for data creators, like for example GEM or ENTSO-E. What they can do in this case is using a power plant matching in order to compare the different dataset or the dataset they have against OSM dataset that is produced by OSM power plant. And they can get the difference between them. And finally, they can collect a kind of a report that finally they can use in order to include those plants that were not in their own datasets. So as I explained before, we aim to present that hands-on activity. But before giving the word to my colleague David, you can scan this code or put this URL into your computer, and maybe you can follow us lively, because we have a collab in Notebook that you can follow this Notebook repository that we have. Before doing that, while you are reaching there, I would like to share you the package, the OSM Power Plan, which is in our platform, in our repository of the organization, Open Energy Transition. And I would like to ask you, please put some stars here in order to support. And at the same time, I would like to ask you to generate pull requests and also issues that may contribute to the work we are doing. This is an open source tool that we hope everyone can use it and improve it together. So what I wanted to say, we have here the description, how we can install the package using pip install, for example. And also there are instructions of basic usage, but at the same time, we have the documentation. So one important parameter or aspect that I wanted to let you know is related on this configuration. This configuration file is the most important in our case. That allows us to collect more plants and reduce the rejected plants. And then this file is the one that helps us to somehow identify most of the processes that we are working on. For example, I just showing very quickly what it contains. And for example, it contains this false refresh, which is false by default, but you can put it as a true, for example, which this is very important whenever you want to download the data directly from internet. I recommend you to put it as a true. But in some other cases that when you want to work constantly with the tool, then you should leave it as a false in order not to constantly downloading data from internet. But also you can see that there are some instructions that, for example, if there are names missing in the data that we collect from OSM, then we allow to pass, or we can leave more strict. And if it doesn't have a name, and then goes to the rejection list. So in this configuration, you can see that most of the parameters that we can modify are related on estimating the capacities. But also, one of the examples that I wanted to show is, for example, related on the source. Here I wanted to show some examples. We collect our final data sets as sources, either biomass, biogas, hydro, etc. But we can find in our data set in OpenStreetMap a very rich and variety of description of those tags. So what we do is try to collect all of them. For example, we can have in Russian language and many other definitions of the same source. Sometimes it's misleading. Here we have solid biomass when we already have other options like biofuels that are, of course, liquid, but it's something that we can try to improve through the time. So, and finally, I wanted to show you the documentation. Here in the documentation, you can have many examples, a lot of description. And finally, here we have the workshop with the activity that my colleague, David Diaz, is going to show you now. And this is the link that you can open the script he is going to be describing now in a couple of seconds. So please, David, I can share you the floor.
All right, thanks a lot, Carlos. That was a really good introduction to what I'm about to show you. So, all right, everyone. So thank you for being here. Given our time constraints, even though this would be kind of like a walkthrough through the Jupyter Notebook Lab, I have everything pre-computed and the outputs are already there. You can do this like while I'm actually talking about it, or later. You can just like ping us again if anything fails. We will be happy to address that. But in a nutshell, what I'm about to show you in this notebook is just a practical way to evaluate the data quality of power plants in OpenStreetMap. What is that? What is this? This is basically, in a specific context of energy system modeling, evaluate if a power plant in OSM falls between all the requirements that we need in order to model properly a system, right? So the key idea is that instead of just having information on our power plants in OSM and not knowing if they are, let's say, good enough for our energy system model, we explicitly test whether they meet modeling requirements, and if not, we have a way to figure out why it didn't work, why it wasn't picked, or why it was rejected, the power plant, and also we offer an option to actually correct this. As we all know, energy models are strict and usually unforgiving as well. If a power plant is missing fuel or technology or capacity, it simply cannot be used, right? And this has meant that historically for many models, OSM information has not been used and it has been excluded somehow because we are not sure of what we have. But with this, now we can test it. And that doesn't mean the information is wrong. It just means that maybe the tags don't yet match our modeling needs. And that's what this does. This bridge the gap and help us turn OSM information into usable data for energy modeling. So that's what we're gonna basically walk through at the moment. It's gonna be quite simple. So I have everything computed, as I said, but you can actually run it by yourself. This is on my local machine at the moment. So as my colleague Carlos said, why this matter? Well, this is basically based on OSM power plant. It fits into power plant matching, and then it can be used either in Pipes.Air, Pipes.Europe, or any energy modeling tools that may apply, right? So it's quite easy. It's quite straightforward. Just a quick setup, importing dependencies, right? Installing them. Then we come to a part where we extract the power plant data from OSM, of course. And then here is where the fun begins, right? We can check, in this case for Colombia, that we find only 17 valid power plants out of all the OSM data that we got. So this means that we have a lot of data that is being rejected by the, let's say, energy modeling requirements, and we gotta know why, right? So why is this? And here goes the reason. We have a certain, let's say, requirements that we can actually configure in the config file that Carlos showed, in which we say, are we gonna allow a power plant to have a name or not? Are we gonna allow the power plant to not have technology? Do we care about the start date of the power plant? And so on and so forth. So if we say, for instance, missing name allowed false, what we're actually saying is we really need power plants to have a defined name. Without it, it will not pass. At the same time, if we say, do we allow if they don't have technology assigned? If they don't, they then don't pass. And so forth, so on, right? So when we process that, we actually came to the result that we have only 17 valid units and 257 rejected ones, right? But that's also because of our restrictions. So what type of restrictions do we get from this? We get missing source type, which is no fuel type has been specified. In other words, it lacks some sort of tag. That tag could be, it doesn't specify if it's solar, wind, or hydro, or other source. Also, it might be that it doesn't have a technology assigned. And this might mean that we're not saying if it's photovoltaic, if it's a run-of-river, if it's a hydro, or if it has a reservoir method. So this type of technology, it's really important for us in order to classify, to be able to classify this in the best way possible. Also, there might be other times, which is basically almost always, where we need the capacity of the power plant, right? And if it's not there, then we cannot use it. So that means that it doesn't have a tag in which the output is specified. And so forth, so on, right? Also, if the name is not there and we need it, it's gonna be rejected. So after we got all this, we can actually keep running the notebook in order to get some GeoJSONs, and this is basically the whole, let's say, the whole reason why we do this. When we get these GeoJSONs, what we're getting are data that we know is not being accepted and that we can later correct so that it's taken into account. So what do we get? We get a GeoJSON per every reason of rejection. What is this? It's basically, in this case for Colombia, the capacity placeholder value, the capacity regions doesn't match, there's no name, there's no output, there's no source, or there's no technology. So when we have this, we're able to correct this tagging if possible and if verifiable, just as my colleagues have been stressing out so much during this workshop. And we can also visualize this. So for instance, when you run this cell, you can actually get a visualization of Colombia in which you can actually see all the power plants that were rejected, and they have been also colored by the reason of the rejection. In this case, I would really like you to focus on this power plant. This power plant is actually a solar power plant. And the reason why it was rejected, it was because it doesn't have a name tag. But that's not only it. So if we can quickly click on it, we go to OpenStreetMap, and we can see that the only tags that this power plant has is source, which is solar, power, because it's a power plant, and then an output electricity of 19.9 megawatts. As you can see, I was the last one that edited this. So I've also been feeding information into this, but here's the trick. What is missing to this? Why has this power plant been rejected? Not only because of the name, but also because it lacks a technology tag. What's a technology tag? Where I have to say, okay, this is a solar power plant and the technology is photovoltaic, right? So even if I correct this and add the name, if I run the whole process again, I will get it rejected once more because it doesn't have technology added to it. How do you correct this? It's quite easy, it's quite simple, and it's quite straightforward as well. I'm not going to go into the details on how to get the environment that I'm going to present to you at the moment. If you want to know more about this, please contact Map Your Grid, and also check all the tutorials that we have online. They're great. Lots of videos as well in order to be able to get to this part. But once you do it, it's quite straightforward. As I'm about to show you, this is JOSM, which is the software that we can use to actually edit tags on power plants. What do we do here? We previously, or at least in this case, I have previously loaded all the Colombian network, including all the power plants, to my let's say, main layer. Afterwards, what I did is basically I took one of these GeoJSONs, in this case the name rejections file, and add it as a hint layer, which is, I know you heard a lot of hint layer wordings during the workshop and the webinar. So this is exactly what it means. It means this. Having a hint layer, it's basically this, having let's say, data and points that you can use to map. So in this case, I have already identified the same power plant, but in OSM, which is this one. And as you can see, it's right here. This is the power plant that is causing a problem at the moment. What does this mean? This means, as you can see here, in this part right here in information, it's missing a name tag, right? Where is this plant in the real OSM data? It's right here. And you can see the same tagging that you could see on the internet, right? So what do we do in order to correct this? Or not to correct this, but to make it well enough for the whole workflow to say yes to this plan and accept it as part of the PIPESA-Air, PIPESA-Europe, or any other energy system modeling tool? Well, we just have to add the tags. So in this case, I just have to add the name, which I have previously verified through official information and public information. So I just add it. And then I just have to add the method, right? And the method is actually verifiable through the satellite image. It's photovoltaic. I think we have no doubt about it, so I can just add it. Once this is done, I can quickly just upload this information and say, here is my reference. I haven't done this yet, but this is the way to do it. Once you do that, you can just come back to the Jupyter notebook, rerun the whole thing again, and you will notice that it won't be rejected anymore. You will have it among the selected power plants for Colombia. So that will mean selected power plants will no longer be 17, it will be 18. And that's basically, in a nutshell, the notebook. So it allows you to check not only one country, you can actually check a range of countries, because you can actually enter them as a list. So it doesn't necessarily mean that it has to be one country at a time. You can do something like this. You can go test countries and test Malta, Luxembourg, Cyprus, Chile, Mexico, whatever. And then you can quickly go through them, right? And as Carlos was saying, if you're a developer and you're into this, then you would not force refresh through, because you will be downloading the information every time, right? So, and then instead you can just like basically download it once and keep it in the cache. So if you have any doubts regarding how to set up this environment with all these tools, please check the Map Your Grid website. Also, we'll be happy to, if you ask any questions about this, or if you send us an email or pin us in some sort of form in any of our socials. And please watch the videos, because they are super interactive, they're super good, and quite informative as well, and easy to follow. So that will be my contribution on my end. I'll just open the floor for questions again. And after that, I'll leave the final remarks to Tobias. Thank you.
Thank you, David, and Carlos as well for this contribution. I would add just a point, because you mentioned many tags actually that you are rightly using according to OpenStreetMap guidelines, and I encourage the audience today to have a look to the documentation that Marina mentioned in the chat, for instance. And just to say that in Map Your Grid, we not only consume the tags of OpenStreetMap, we also contribute to the development, and we invest some time last year about the refinement of the tagging of power plants. We thought that some improvements could be made on that matter, and we written, let's say that's the usage, written a proposal that should address the improvements we think are right to be made. You can read it. I won't go through the whole explanation of the proposal process, obviously, tonight, but you can read it and have an idea of what it's all about and how it goes to improve the tagging and provide relevant insights about the ontology and how we can improve the description of some crucial assets like power generation ones. So that's part of our work as well, and it completes the process we provide on the generation assets that Carlos and David showed. If you have any more questions regarding that, we can discuss it a bit before the conclusion.
Hello, everyone. This is Andres Flores from El Salvador. I like to start saying by thank you for all the great work that you're doing. I think it's very transformative, and the impacts of this are going to be seen, are being seen today, but also are going to have great ramifications in the years to come. So thank you for that. I had a question in terms of transmission lines. I noticed when I go into the map, basically, that we can see voltage levels, so we can see how they're connected through substations. But is there a way or a tool to either estimate that the values are in there to get impedances, to get power transfer distribution factors, or estimate that? Those are very, very important in different studies.
Thank you for a question, actually, because that was the point where we discussed how to map some circuits, so over the physical network, to know the routes that power is following, and obviously each circuit has a given impedance and physical properties. But currently in OpenStreetMap, we don't use to map that. As mentioned before during the Katya's presentation, we used to link the topology that may contain some business indicators, business reference, business codes. The local operator give codes to or names to the circuits and assets, and we can make the bridge between what OpenStreetMap is providing and the open data that may mention, for instance, static grid model that may mention some physical properties. So we better linking them instead of providing them in OpenStreetMap. There's currently no way. We propose that to have the tags to state the impedance and the reactance and many things, on assets, but it was kindly discarded because that's not really suitable and not really verifiable as well by the community. So we didn't take the risk to put that knowledge in the database and invest our time to make bridges between datasets. David, you can complete if you want.
Yes, thank you so much for the question. So in a nutshell, the reason why we don't add or we don't have these physical properties is because it's really hard to verify them with a satellite image, and it's really hard to just like see them on the street, right? So what we do instead is we take the infrastructure of OpenStreetMap and everything we can, transmission lines, poles, power lines, and generation assets, and then we combine this with other data sets that we could have regarding physical properties. So in the case of Colombia or Bolivia or other countries where this might be publicly available, then we take this information and we combine it with the network that we created from OSM. And that's the way we do it. Because we cannot have this type of information in OSM, as it is really hard to verify and there's no tag for it at the moment. So the convention is map what you can in OSM, what you can see, what you can verify, and then the rest of it from a modeling perspective, you have to take it from some other source or some other data set that you can get. If it's public, or if you're working in a TSO or in a private institution, you may have that already, and you can just like form your or get your network from OSM, compare it to what you have, and then add all your private data to the whole system or to the whole model. Sorry. So that would be the way.
Precisely. Thank you, David.
Maybe to add on this, it depends on like with this line type catalog that Katja introduced, depending on the resolution that you want to resolve, then if you're just interested, let's say, on a more regional level, on more what are the capacities of these two regions, how they are connected, then this can be modeled with PIPESA and the OpenStreetMap data using the voltages, if you have all the voltages, if you have the circuits, the numbers of cables per line, and if you have the line type catalog per voltage, like Katja used for Bolivia and for Colombia. And if you use then PIPESA, you can estimate it. But these are only estimations. And I don't know your use case. Depending on use case, you should not work with estimations, but you want the real numbers. And we have to create this list. And for example, for Bolivia, for Japan, for Canada, for many, many countries, you actually have the capacities per line. So just reach out to us and we can also have a look. Sometimes you just find this information. You also find it for the US, for example, but there you find it more on a regional level.
Thank you. That's very helpful information.
Okay. François, should I continue?
I think, yeah. Thank you, Tobias, for the conclusion.
Okay. Let me just go through the slides again. There we go. So, yeah, I wanted to give you some numbers and some ideas that you can maybe remember that are easy to remember, and it gives you, let's say, a broader overview about the quality of this data and a little bit also where we want to go. And at the end, also a little bit how you could support all of this. So in general, I must say it's a very good data set. So I personally, and a lot of our team, we looked 1 year daily against this data and satellite imagery, and it matches always. That's an important point. So what is there matches with reality. There is no, you see not really a lot of, let's say, non-existing lines or fantasized lines in this data set. It's very important. what is really missing, there are some gaps, especially in China and India. They are the biggest, let's say, coverage gaps. But you will find in very different countries sometimes missing voltages a lot and circuits, and they are relevant. And you should be careful when you use the data and just have a look that not too much circuits or too much voltages are missing, because then you will always underestimate your grid. So we did not anything say about how to get the data. You get the data with our editor. You go to Map Your Grid and then you click on data, and then you find there explained how you can actually download it. On the coverage side, we estimate at the moment, using all those global grid index that we created, a coverage of 76% of transmission grid defined by plus 50 kilovolts. Okay, so most of the data is actually missing in China. If you just remove China from this equation, we end up actually by 85%. Then another important thing is this data is really created with satellite imagery. A lot of people think it's created with other data sets. We use other data sets as hints to find in the imagery than the infrastructure, but it's always a completely different data set. That's why it is always different, for example, to a data set from a system operator. For example, it includes sometimes private lines that are just not being operated by the public system operators. So it's really crucial for us. As a rule of thumb for you, the higher the voltage, the bigger the infrastructure, the easier it is to map, and that's why it has better quality. This is something that almost always works. So you can say really above 200 kilovolts, the quality is in all countries really significantly good. Also in China, India, doesn't matter. Because the infrastructure is so big, it's easy to detect. It's also easy to see with a lot of different imagery. And that's why it's good quality, because it's not that hard to map and a lot of people could verify it. So the data really affects a lot any energy system model or any insights you want to create are affected by the quality of this data. So we said this on the first slide, I think it's called the trash in, trash out principle. Sometimes if you just want an order of magnitude, it's not that relevant. But if you want something precise, something accurate, if you want to show how things are processing over time, then it's really important to look into the quality of your data, and we can help you there. So it takes some regional expertise, also on the modeling part. And that's an important point. As an energy system modeler, you can create local expertise by mapping. I'm personally convinced that a good energy system study should start with a little bit of validating your data in OpenStreetMap and just looking at it, because you learn how the infrastructure is looking like. Where is your hydropower? So it gives you quite good understanding. In total, we mapped, the whole grid was growing by 56% in OpenStreetMap. We did roughly half of it. We see now that the data is actually saturating. That means more or less the lines missing getting harder and harder and harder. It's just that what is missing in OpenStreetMap is hard to map. That's why we need to support this community. That means if you're using this data, consider supporting community. And maybe the last words, this power plant matching tool is very interesting for us and everyone who wants to validate data. So you can use, you can use another data set and compare it with OpenStreetMap. For example, the locations can be compared. You can extend another data set and you can enhance your data set with it or the data set within OpenStreetMap. Then maybe this is really important to say. So it's really that this is, let's say, a crowdsourced data set. So the grid needs more or less you. And since we want to maintain this data for the next, 20, 30 years to come, we have 4 different pillars that we are setting here. One is that we as Map Your Grid are offering actually not training and services around how to use the data, how to improve actually system operator data, closed data, and every data with OpenStreetMap. What we also are seeking is more philanthropic funding, more to pay mappers, but also to expand the tooling, the quality assurance tooling, for example. Then another very important pillar is really the OpenStreetMap community. Most of the data is being done by the broader OpenStreetMap community. And to empower them, to support them, this is also something we are looking into. And then the final word is data users. So there's so many data users out there that we are investigating. It's really it's a job itself to investigate the data users. But we sometimes don't know really the data users because everyone can just download it from OpenStreetMap. But we really, if you're using this data, consider if you find a better source for anything, if you find a better map, if you want to contribute, if you find an issue, everything can help there. We can empower you to map the grid. We can also empower you to use the data. That's no problem. But it's really that as a user, a little bit of contributing back can help us a lot. And if it's just putting a LinkedIn post, I use the OpenStreetMap data. Thank you so much for this. This is also very helpful. Our mission is really to empower you to understand and improve the data you're using. And I don't say open data here. It can be any data. So let's say our main interest is actually to improve grid data quality in general worldwide, not just what is in OpenStreetMap. OpenStreetMap is a key solution to do this. And you can go to Map Your Grid. You can also go to the Pipesa Earth website if you want to use Pipesa. We've missed this there, but it's you can join our Discord. We're sharing a Discord together with Pipesa Earth. We have a lot of YouTube videos. We have this 2 weekly daily mapping together. And one thing is really you will receive free personal training in grid mapping by us. Just reach out. I train you personally. In your country, in any use case that you're looking into, we train you on doing this. And it's really a pleasure. Thank you so much. And I think maybe also François, thank you so much for moderating this. You can also want to say something, François, some final words.
Sure. Thank you, Tobias. I also thank you for attending and meeting us in this webinar. That was kind of first experience we had to going public in such an event, but I hope there will be some another opportunities to get in touch. I didn't add this page, but that's really relevant. We will be at FOSDEM. You can meet some of us there in Brussels. That may be a pleasure to discuss about open source software and open data, about ProGrids. We may have another events online as well, and feel free to get in touch on the appropriate channel you may see here. Thank you, guys, and see you probably soon or later. Bye-bye.
Bye. Thanks so much.